still within the Stramenophiles. Of SAR. Another very important phylum, one of my favorites, is the Bacillariophyta. And the Bacillariophyta, they are photosynthetic, they are algal. These have the common name of the diatoms. And diatoms have a number of important uses. Diatomaceous earth is essentially mined from oceanic deposits where the siliceous tests, the frustules, are accumulated in like the just legions, like trillions and trillions of these little microscopic glassy frustules accumulate. And so they have all the properties of finely ground glass. They're abrasive. They can be used for filtration. They're used as an ingredient in things like toothpaste. They can also be used as an insecticide because insects will, if they walk across a line of diatomaceous earth, it will abrade or scrape up their exoskeletons and cause lethal damage to them. Diatomaceous earth is actually one of the ingredients in dynamite, as it turns out. So a lot of uses for the diatoms. Another one use for diatoms is if you take a breath and let it out, about 1/4 of the oxygen that we breathe is thought to be produced by diatoms. So they're out there in oceanic habitats and freshwater habitats, photosynthesizing, and there's so many of them that they really make a significant contribution to the oxygen cycle. And if that wasn't enough, the petroleum reserves on our planet, petroleum is a source of hydrocarbons that we can refine into things like gasoline and diesel fuel and motor oil and plastics and. I mean, it is a very, very important resource that we have exploited in the past 200 years or so. And a lot of people think, oh, petroleum, that was because the dinosaurs got fat and died and they, got turned into oil. But it's really, there weren't that many dinosaurs around to produce the reserves of oil that we have in the world. Most of the world's petroleum oil reserves are the product of ancient photosynthesis over the periods of hundreds of millions of years. And a lot of that was put together by diatoms. So diatoms plus pressure over time equals petroleum. And that's an oversimplification. I'm not a petroleum geologist, but I do know that diatoms are important for that as well. So hopefully I've impressed upon you that these organisms that you've never heard of are very important in your life. So diatoms, they can be solitary or they can be colonial. But one thing about them is they always produce this two-part this frustule has two valves. Okay, so they kind of look like if you've seen a petri dish in the lab, often they can be centric, meaning they are radially symmetrical, or they can be kind of bilaterally symmetrical. They can be pennate, so centric or pennate. In this case, I'm just kind of trying to draw like a centric diatom that looks just like a petri dish, but you're just looking at it from the side. And the organism itself lives inside of there. And so we've got these two parts to the frustule. I guess just connect them together there. And when these organisms go through mitosis, they reproduce asexually. Each one of the daughter cells is going to get one of those valves. But the interesting thing that happens is when they reproduce and they have one valve each, which means they have to reproduce that second valve. That's easy for this guy here because it's just going to make one that nests inside that top half there. That bottom half there, there's a rule for diatoms, which is they can only replace the inner valve of the frustule. So that means that this guy is going to be a little bit smaller than this guy because this one is new, that one is old, that one is old, that one is new. So as this one goes on, it's going to keep essentially replicating and having the same size. But as this one continues to replicate, okay, so you've got the bottom half here, which is going to make itself a new valve. And the top piece, which is nested inside, well, now it's going to make an even smaller inner valve. And that's just going to keep going and going. So this guy's going to get smaller. And this guy's going to get smaller. And then this guy's going to get smaller. And that's all asexual reproduction. And then the funny thing is, when they get too small, they can't just do this forever until they're, atomic. Or that doesn't work. But when they get really small, that's when they undergo sexual reproduction. And they'll undergo meiosis. And those cells will go back to making full-size frustules. Yeah, I'm kind of squeezing them in here. So that's kind of the interesting story of the reproduction of diatoms. These frustules they're like microscopic jewelry. They can be quite beautiful. The sculpturing on them, they are not just like petri dishes. They're like petri dishes that have been finely engraved with intricate patterns that, you look at them under the microscope and they can be very beautiful. And I have not done them justice at all through my drawings here, but hopefully this makes sense, this way that diatoms can kind of continually get smaller and smaller and smaller. And I just think it's kind of funny that it's like when they get small enough, that's when they know it's time to have sexual reproduction. All right,